In section 3.30 of polynomial functions, example number 2, we want to know, is x plus 3 a factor of x to the fourth minus 81? We can use synthetic division. If the remainder is 0, we know that x plus 3 is a factor of x to the fourth minus 81. Setting up our synthetic division, we're going to use a -3 in the setup because we want to know if x plus 3 is a factor. We put a -3, which would make that factor equal to 0. And then setting up, remember that we want to make sure we have all of the exponents represented. So beginning with 1x to the fourth, there is no x to the third, so we have to put 0x to the third plus 0x to the second plus 0x minus 81. Our setup then uses the coefficients 1, x to the fourth, 0x to the third, 0x to the second, 0x to the first, and -81. Now bringing down that first leading coefficient and then multiplying and adding. 1 times -3 is -3. 0 plus -3 is -3. -3 times -3 is 9. 0 plus 9 is 9. 9 times -3 is -27. 0 plus -27 is -27. And -27 times -3 is positive 81, leaving us a remainder of 0. Because we have a remainder of 0, we can say yes, x plus 3 is a factor of x to the fourth minus 81. So x to the fourth polynomial is a fourth degree polynomial, which means it could have 4 possible factors. So another way of looking at this is using our techniques from before. How do we factor polynomials? Well, there are certain special model type of factoring. For example, if we have a difference of squares, if our polynomial can be written in the form of a perfect square minus a perfect square, then the factors are a plus b and a minus b in our model equation. Now, x to the fourth is a perfect square. In fact, we can write it as x squared to the second power. And 81 is also a perfect square, which we can write as 9 to the second power. So we can factor into 2 binomial factors where the first factor is going to be x squared plus 9, and the other factor is x squared minus 9. Now we have found using synthetic division that x plus 3 is a factor. So we could factor this even further, since our x squared minus 9 also falls into this model equation, a squared minus b squared. It's a difference of 2 squares. We can then factor this as x plus 3 and x minus 3. Now the x squared plus 9 is a sum of 2 perfect squares, and that is a prime polynomial which cannot be factored. So the factors of x to the fourth minus 81 are 1 factor and a second degree factor, x squared plus 9, and we have 2 linear factors, x plus 3 and x minus 3. In example 3, we want to use synthetic division to show that g of x is a factor of f of x, and then complete the factorization. I want to point out a mistake that's on the handout, so just make that 3 a 2. I unfortunately forgot to correct that on the handout, but go ahead and make that correction. And we'll go through the process of synthetic division to show that x minus 2 is a factor of this polynomial. This is an x to the third degree polynomial, which means that your graph could go in 1, 2, 3 directions. It means that your graph could have 3 linear factors. And it also means that your graph could cross through the x-axis in up to 3 locations. So let's look at setting up the synthetic division to show that it's a factor. And then what's nice is what's left over can then be factored as well. So we're going to set up synthetic division with a 2 in the box using the coefficients 1 x to the third, negative 2 x to the second, minus 4 x, and 8. Using synthetic division, we bring down that leading coefficient of 1, multiply and add, and then multiply and add. So we end up with a remainder of 0. This is key because since we end up with a remainder of 0, we know that x plus 2 is a factor. Now, what's nice about synthetic division is that we can use what's left over here to find another factor of that polynomial. Since we are essentially dividing x to the third, this third degree polynomial, by x minus 2, this is our quotient part and 0 is the remainder. So we can say that this is a factor. If we divide out that x plus 2 factor, what would be left over is the quotient. And since this was an x to the third and we're dividing out an x factor, we're going to reduce that exponent by 1. So it's going to be 1x squared plus 0x minus 4. And the other factor is going to be x squared minus 4. So this is an x to the third polynomial, which means we could have 3 factors. Right now we have 2 factors. We have one linear factor and one squared factor. That means we can factor this even further. This also fits into that model equation of a difference of 2 squares that is factored into a plus b and a minus b. So our factors are x plus 2, and then x squared minus 4 can be factored into x plus 2 and x minus 2. So another way we can write this polynomial function, notice that we do have repeated factors. X plus 2 is repeated twice as a factor, and x minus 2. We'll get back into how this relates to the graph in just a little while. Let's look at example 4 and factor. First, we want to use synthetic division to show that x plus 2 is a factor of that polynomial. It's a third degree polynomial. We're going to set up the synthetic division by putting a negative 2 in the box. Since we're showing that x plus 2 is a factor, that means we're dividing out x plus 2 and using the coefficients 4 x to the third minus 5x to the second minus 23x plus 6. We're bringing down that first term, first leading coefficient, 4, multiplying, and then adding, and then multiplying, adding, and multiplying. With a remainder of 0, we know that x plus 2 is a factor of that third degree polynomial. So our polynomial f of x can be written as one factor of x plus 2. I know we had a negative 2 in the box. That corresponds to the factor of x plus 2. And the remaining, the quotient part here is another factor. Since this was an x to the third power, we're going to reduce that power by 1, x to the second, and x, to get 4x squared minus 13x plus 3. Now this is a trinomial. We can factor the trinomial using the AC method. And I'll do a quick review of the AC method. Since it's in the form of ax squared plus bx plus c, we multiply the a and c together and find the pairs of factors of AC that add up to the middle term, b, and then we are going to split the middle term, and then we're going to factor by grouping. All right, so this is going to look like we're trying to factor this 4x squared minus 13x plus 3. Using the AC method, I'm multiplying 4 times 3 to get 12. I find all the pairs of factors of 12, 1 times 12, 2 times 6, 3 times 4, negative 3 times negative 4, negative 2 times negative 6, negative 1 times negative 12. So you want to find the one pair of factors that will add up to the middle term here of negative 13. And that is negative 1 times negative 12. So we're going to split the middle term. We write the first term, 4x squared. We're splitting up the middle term into minus 1x, minus 12x, and write that last term of plus 3. Now we're going to factor by grouping, looking at the first 2 terms and the last 2 terms, what they have in common. You can factor an x out of the first 2 terms. Dividing out that x factor, we're left with 4x minus 1. And for the last 2 terms, we're dividing out a negative hold on a second. Okay, dividing out a negative 3, and that will be left with 4x minus 1. Notice that 4x minus 1 is a common factor, and then the x minus 3 is going to be the other factor. So we can write this as one factor of 4x minus 1 and the other factor of x minus 3. Going back now, completing the factorization of this polynomial, we want to write it as, if possible, 3 linear factors. So one factor is x plus 2 that we found using synthetic division, and then the part that's left over, we used the AC method to factor and found that those 2 factors are 4x minus 1 and x minus 3.